You may be familiar with my first world problem of always giving out about the battery life of equipment such as phones or laptops. And not just that you have to recharge them a couple of times a day, that after a year or two, they just start dying on you, and that expensive piece of equipment has to be replaced for a very big cost. But it always struck me that nobody would ever want to give you an everlasting battery, a bit like an everlasting gobstop from Willy Wonka and the Chocolate Factory. But our next guest may be able to do so. Professor Valeria Nicolosi, how are you?
Very good. Thanks very much for having me here.
Now, you are principal investigator at AMBER, which is?
It's a centre, a Science Foundation Ireland funded centre for material science.
Okay. And you're looking for an everlasting battery, or is that too shorthand a way of putting it?
It is a little bit a short way of putting it. It's a little bit more complex.
Okay.
But yeah, we are looking for making batteries more efficient and long-lasting, indeed.
Okay. How can you do that?
We are using a set of new materials that are not used in commercial batteries just yet. I'm talking about the flattest materials known to man. So we have heard a lot about the hype of graphene, and a lot of even kids have heard about this word. What graphene is a very special material which is only one atom thick. It comes from a very common material in the first place, graphite, which you can find in the pencil's lead, for example. What you find in the pencil's lead is a graphite, which is made of many different layers, millions of layers of graphene stacked one top of the other. Eventually, if you can isolate only one layer out of that graphite piece, you get graphene, and it's a material that has wonderful properties.
And is it visible to the naked eye?
It's not visible at the naked eye, absolutely not, but it's visible under very, very sophisticated electron microscopes, for example.
Okay.
So you really need special equipment to see it. What is important about this material is that it behaves completely differently to the material it comes from. So it's transparent, it's extremely strong, it's 100 times stronger than steel, if you think. It conduces electricity way better than copper. So it's one of these wonderful materials. And within my research group, we actually expanded the set of these materials. Actually, graphene is not the only thin material in nature.
Okay.
And we found about 500 different ones, actually, similar to graphene, that can be thinned down to the thickness of an atom. But the wonderful thing is that each one of these 500 materials behaves differently. So some materials are actually very good for making batteries, and that's the novelty. So, and you can mix and match. For example, we add graphene to make them stronger and to achieve some mechanical robustness.
So what's your ambition? Is it that it's something that would be recharged very quickly, so that almost instantaneously, rather than having to be left plugged in overnight? Or is it something that might only need to be recharged once a week, once a month, once a year?
Actually, it's both things and plus another one. So we are effectively building energy storage devices which can be charged and recharged within fractions of seconds rather than hours or nights. Second,
energy surge devices.
Storage,
okay.
Yeah. So batteries, effectively,
okay,
that can be charged and discharged very quickly.
Okay.
But also that can last very, very long. Much longer than the batteries. What you were initially saying about buying a device, a laptop, a smartphone, and needing to plug it maybe once a day to begin with. At least. And then after 6 months, you already see that you actually have to plug it all the time.
Yes.
In order to function.
Yes.
And that is because the battery, if you do a little experiment like a kitchen experiment, you open the battery. Don't do that because it's very nasty. There are very nasty things inside the battery. But if you would open it, you would actually see that the battery is all crumbled, is completely mechanically destroyed. And this is because every time you charge and discharge your battery, the way it works is with this little ion, lithium ion, going in and out. And every time these little ions get in and out, destroy the electrode, that destroy the battery.
Okay.
What you avoid using these very special materials is this mechanical damage that is
But Valeria, how close are you to actually making this a commercial product that the various phone manufacturers and laptop manufacturers would actually put into their products?
We're not that far. We have prototypes already in our hands. And there's been a lot of investment from many different sources. The European Research Council, for example, Science Foundation Ireland have heavily invested in this research. So what we're talking about today is actually, it's not the beginning of the research. We've been working on this since years.
But would you worry that many of the manufacturers of products would actually try to nobble you, put you out of business on the basis that they like the idea of the batteries dying over time because it's the death of the battery which makes you go and buy a new phone or a new piece of equipment?
I think you would still buy a new phone or a new piece of equipment.
For the upgrade of the software.
Exactly. But they would all like the idea of selling something that it's lasting longer over the competitors. So, and
but at what price? See, this is the other thing. How much will one of these batteries cost to put into?
You'd be surprised. Much more cheaper.
Really?
Much cheaper than all these materials I mentioned. They're extremely cheap, plentiful in nature. And that is the secret, actually, not going through complex materials. It's been under our eyes. The most important thing that we have learned over the years is how to handle these materials and how to make useful devices.
You're hardly the only person doing this, are you?
Of course not. There is a huge race worldwide. There's a lot of
Where
competition.
are you in the race, do you reckon?
I'm pretty good.
And are you using it in any of your own equipment? Have you used the prototypes in your own phone or anything else?
No,
that?
not at that level yet. We are testing them in the lab, and we're pretty pleased with our results. Also, it's important to say that all this variety of materials can actually be used to generate devices that are used for different things, because not all appliances will demand the same amount of energy.
Yes.
So, for example, we have developed a way of processing these thin materials in liquid and making inks, and we are printing these materials, printing batteries with almost conventional inkjet printers on the shape and on the size that you want, almost on any surface. So on plastic, on paper, on anything you want to print them on. And this is, for example, some type of technology which would be especially beneficial for food packaging, where you have, for example, a particular sensor, a gas sensor, or something that is powered by a battery embedded into it that will tell you whether your food has gone off or not.
It sounds brilliant. You've been getting the money in Science Foundation Ireland, from Science Foundation Ireland, for your work at Trinity College Dublin. You've actually had quite a good amount of money in.
Absolutely, both from Science Foundation Ireland and the European Research Council. So I've just been awarded a European Research Council Consolidator Award, and that is €2.5 million to actually bring this research to the next level.
How many people do you have working on the project with you?
At the moment, my group is made of about 25 people.
Okay.
Yeah.
It must be fascinating work, is it?
It is indeed. And it's always, the fascinating part is that every day is different. You learn more and more by the day, effectively. So what I'm telling you today might be outdated tomorrow.
But then, I don't want to sound in any way negative, what if you don't actually manage to be the first to develop this product?
It's a continuous race.
Never ends.
It never ends. Absolutely not. You might lose a leg of a race, but at the end, you have many other opportunities. So that's the thing. It's just being aware that you are in competition with a lot of other people worldwide.
Professor Valeria Nicolosi, thank you very much for joining us here on The Last Word today, and best of luck in your endeavours.
Thanks very much.